Alright, welcome to another Benedict Research Labs training video. Today's Dr. Dan Patel is going to show us how to set up and check for safety a distillation apparatus. Go Dan.
Thank you, Jason. Well, the first thing you'll notice is that the sash is actually up all the way, and this is more for clarity than anything else. Anytime you're doing any sort of chemistry, the sash should actually be at the minimum level to get proper flow, and then pulled down once the reaction is going and you no longer need to be fidgeting with stuff in the hood. So what we've got here is a distillation with THF, and we've got a source flask that's going to be heated by a silicon oil bath, and we're going to control the temperature using our temperature control probe and the hot plate itself. It's going to go through a distillation head into a receiving flask, and you'll notice the receiving flask is set up with an ice bath. This is to ensure that the THF, once it works its way through, if any has not condensed in the condenser, it'll actually condense in the receiving flask due to the cold bath and not work its way into the line, thereby causing a mess that you're going to have to worry about cleaning out later, possibly damaging some of your equipment. One of the many things to take care of when doing a distillation and when setting one up is to make sure that all of your joints are properly greased and are actually sitting very, very snugly. You don't want any loose joints, because once that THF starts boiling, the vapor is going to leak through the joint and not make its way through your distillation setup, and it's going to be a loss of THF, and you're going to have to do this all over again. We've got a stopper and a thermometer here to cover up these two joints. We could put a thermometer here. It's not really necessary because we know this is THF. We know what boiling point we want. We could put a stopper here. Again, we don't need the thermometer, but this is more just if you were distilling an unknown sample, the thermometer would let you know the boiling point of your material. So once you've got everything situated and everything clamped in place, you want to make sure that not only are the joints secure, but that the clamps themselves and that everything is set up, that nothing is going to move or fall during your distillation. And an added measure of safety is actually this lab jack that is partially being propped up, or at least the cold bath being partially propped up by a cork ring and this piece of wood, and that actually is adding some support to the receiving flask. So if these clamps fail, we don't have to worry about the receiving flask falling down, losing our THF, causing a mess, possibly even causing a situation where a fire could occur. So now that everything is set up, we've got our nitrogen inlet, we've got the chiller set up with the condenser, and this is set up, this is how a distillation or a reflux should always be set up. You've got cold water or cold liquid, in this case it's ethylene glycol water, cold liquid coming in through the bottom portion of the condenser and then exiting through the top, and that's just to ensure proper condensation as the distillation occurs. So now that we've got everything set up, the stir bar is going basically at a maximum rate such that there isn't vigorous splashing of the whatever solution you're distilling, and we're ready to turn the heat up. And so THF boils at about 67 degrees, and so a good rule of thumb is to heat the oil bath to about 10 degrees higher. But I found with THF, usually going about 20 degrees, maybe a little more higher with the oil bath temperature is good enough. So we'll go to about 87 degrees. And then to help the distillation occur, we want to insulate the parts of the apparatus that are before the condenser, and so to do that you just simply wrap some aluminum foil around the condenser, or sorry, around the distillation head. So once that oil bath reaches temperature of about 87, we'll have THF distilling and then collecting in our receiving flask, which has, based on our other video, some pre-dried molecular sieves just to ensure that the THF stays dry during the distillation and then after it's been collected and has been sitting on the bench top for a while. So there you have it. Distillation of THF.
And with this particular hot plate, we want to triple check and make sure that that temperature probe is in fact in the oil bath.
Right. A temperature probe will do you no good if it's sitting out in the air. That's just going to cause a feedback. The hot plate is going to be reading room temperature, and so it's constantly going to be heating your oil to a point where this solvent is going to be boiling so violently that it's either going to cause joints to come apart, a stopper to shoot out, and you're essentially going to lose all your solvent. And because we've got sodium in here, that would lead to an even more dangerous situation, because now we've got molten sodium to worry about. And then one last thing is, if you're distilling ethers, peroxides are also a problem. So you don't ever want to distill to dryness. You always want several milliliters of whatever you're distilling to be left behind before you stop the distillation.
All right. Well, thank you, Dan.